You know what's wild to me, after years of medical school, residency, and sitting across from patients every single day, is that most people think cancer is something that just happens to you out of nowhere, like a lightning strike. And I get it. That's the story we've been told. You get the diagnosis, and then the doctors step in with surgery, chemo, radiation, the whole arsenal. And that's when the real fight begins. But here's what I want to share with you today. That story, that framing, is incomplete. And I'd go further and say it might actually be doing you harm. Because the truth is, the fight starts way earlier. And most of us, right now as you're listening to this, are already in the middle of it. We just don't know it. So today, I want to walk you through something I genuinely find fascinating. It's a concept I call the ballpoint pen rule. And by the end of this conversation, I think you're going to look at your grocery list and your dinner plate completely differently. Here's a fact that I want you to sit with for a second. Right now, as you're sitting there listening to me, there is a very high probability that your body is hosting microscopic tumors. Not one person in this room is exempt from this, including me. We all, at various points in our lives, develop these tiny clusters of rogue cells. Now, before you start spiraling, stay with me, because this is actually the good news part of the story. These clusters, when they're small enough, we're talking about a cluster no bigger than the tip of a ballpoint pen, they are completely harmless. Completely. They sit there, silent, doing essentially nothing. And the reason for that is deceptively simple. They have no blood supply. Think about it like a city with no roads leading to it. No roads means no trucks. No trucks means no food, no fuel, no supplies. That little cluster of rogue cells, same principle. Without a dedicated blood supply, it simply cannot grow. It can't get the oxygen it needs. It can't get the nutrients it needs. It's stuck. And here's the thing that blew my mind when I really started digging into this literature. The vast majority of these microscopic clusters never progress beyond that stage. Your body and these little clusters essentially reach a kind of stalemate. They coexist. You live your full life, and you never even know they were there. But, and this is a big but, cancer is extraordinarily clever. There is a process called angiogenesis. And if you take nothing else from today's conversation, I want you to remember this word. Angio, referring to blood vessels. Genesis, the creation of something new. So angiogenesis at its most basic is the body's process of building new blood vessels. Now this is a good thing in many contexts. When you get a wound, your body uses angiogenesis to heal. When a fetus is developing in the womb, angiogenesis is essential for building an entirely new cardiovascular system. It's a beautiful, vital process. The problem is that cancer figured out how to hack it. When a tumor reaches a certain threshold, and we're still talking microscopic here, it can begin secreting chemical signals that essentially trick the body into growing new blood vessels toward it. It hijacks a survival process and turns it into a growth engine. And once that happens, the math gets terrifying. A tumor that had been sitting dormant, harmless, the size of a pen tip, once it gets that blood supply, can expand by 16,000 times in just 2 weeks. That's not a typo. 16,000 times in 2 weeks. That is the tipping point. The difference between a cluster your body manages quietly in the background and a diagnosis that changes your life. So, the question becomes, is there anything we can do to influence whether that tipping point is reached? And the answer, backed by some genuinely remarkable science, is yes. Now, I want to be crystal clear here because I know how this can sound. I am not telling you that eating blueberries cures cancer. I am not telling you to throw away your prescriptions. That is not what this is about. What I am saying is that there is a robust, well-researched body of scientific literature. using the same methodological standards we use to test pharmaceutical drugs, that demonstrates certain foods have powerful anti-angiogenic properties. Let me say that again, because it matters. The same testing standards we use for cancer drugs, not some loose, hand-wavy observational study. The real deal. Dr. William Lee, and if you haven't come across his work, I highly recommend it. He and his team have identified over 100 foods that, when tested in the lab, demonstrate significant anti-angiogenic activity, meaning they help prevent that process of tumors recruiting new blood vessels. And when he describes his experience in the lab, I think it really captures something important. He talks about dropping green tea compounds, specifically polyphenols, and one in particular called EGCG, into a pharmaceutical screening system. This is the exact same system a major drug company would use to evaluate a new cancer drug candidate. And the results came back so strong, so compelling, that if you didn't know what you were looking at, you'd think you were looking at a blockbuster drug. Think about that for a moment. A cup of green tea in a pharmaceutical-grade screening system, performing like a billion-dollar drug. Now, the reason I find this so philosophically interesting, beyond the science, is what it says about the relationship between food and medicine. We have this tendency to separate the two. Like medicine is the serious stuff, the stuff you get from a pharmacy, and food is just fuel, just sustenance. But biology doesn't see it that way. Your cells don't know if the EGCG they're encountering came from a green tea bag or a pharmaceutical capsule. The molecular interaction is the same. And beyond green tea, we have a roster of foods that show this same effect. Tomatoes, and I'll come back to tomatoes because there's a crucial nuance about how you eat them. Red wine, which contains a compound called resveratrol. Certain berries, certain spices. The point is this: every time you sit down to eat, you are making a pharmacological decision. You are choosing which compounds to flood your bloodstream with. And some of those compounds actively support the mechanisms that keep those tiny clusters of cells at the pen-tip stage, right where you want them. I think that's profound, and I think it deserves more attention than it gets in most clinical conversations. All right, I want to spend a few minutes on something that genuinely frustrates me in my clinical practice, because I hear about it constantly. And that's the idea that soy, specifically soy products, cause breast cancer. I've had patients come in, women who are trying to eat healthier, women who have a family history of breast cancer and are proactively trying to make good choices. And they tell me, "Oh, I cut out soy. I heard it feeds breast cancer." And every time I hear that, I have to take a breath. Because that belief, and I use the word urban legend deliberately, is not only wrong, it's the opposite of what the science shows. Here's where the confusion comes from. Soy contains compounds called phytoestrogens. Phyto means plant. So phytoestrogens are plant-based compounds that have a chemical structure with some similarity to human estrogen. And I get why that's scary on the surface. Because some breast cancers are estrogen receptor positive, meaning they use estrogen as a growth signal. So if soy has estrogen-like compounds, wouldn't that be a problem? Here's the critical piece of biology that gets lost in the headline. Plant estrogens are not human estrogen, and at the level of the receptor, meaning the molecular lock on your cell that estrogen is supposed to bind to, these plant compounds behave very differently. What the research actually shows is that phytoestrogens tend to act as estrogen blockers. They bind to the receptor, they occupy the lock, but they don't turn the key the same way human estrogen does. So in fact, they can prevent the body's own estrogen from binding and triggering that growth signal. It's like sending a decoy into a lock so the real key can't get in. And on top of that, and here's where it connects back to what we were talking about earlier, soy compounds also demonstrate anti-angiogenic activity, meaning they have been shown in research involving actual breast cancer patients to help inhibit that blood vessel recruitment process. So, To summarize the soy situation, the very thing people are afraid of is actually acting as a shield, not a threat. Now, I'll add one caveat, as I always should. Context matters. Highly processed soy products, your soy protein isolate powders, a lot of processed meat substitutes. That's not the same thing as whole food soy, tofu, edamame, tempeh, miso. The evidence is strongest for whole, minimally processed forms. As with most things in nutrition, the closer you stay to the food in its natural state, the better the story. But the bottom line is, if you've been avoiding edamame at the sushi restaurant because you're worried about your breast health, you can order it with confidence. Okay, let's talk about broccoli, because this is one of those vegetables that most people know is good for you, in a vague general sense. But I want to get specific, because the specifics here are genuinely exciting. And there are some practical takeaways that are so simple that I'm almost annoyed we don't talk about them more. The active compound in broccoli that we care most about is called sulforaphane. And sulforaphane belongs to a family of natural chemicals that are also responsible for that slightly bitter, distinctive bite that broccoli has. If you've ever wondered why broccoli tastes the way it does, that's sulforaphane talking to you. Now, sulforaphane's main claim to fame in the immune system context is that it activates and amplifies your T cells and your natural killer cells. These are the heavy hitters of your immune surveillance system, the cells whose job it is to patrol your body, find aberrant cells, and eliminate them before they become a problem. Think of them as your body's internal security force. And sulforaphane is essentially their training program and their energy source rolled into one. Now here's the first thing I want you to take away from this section, and it's almost embarrassingly simple. Don't throw away the stems. Most people, myself included before I learned this, eat the florets, the treetops of the broccoli, and toss the stems or leave them aside. But here's the thing. The stems actually contain approximately twice the sulforaphane concentration of the florets. Twice as much in the part we're throwing away. Now I understand the texture issue. Stems can be a bit tough, a bit fibrous. If that's the problem, here's a practical solution. Blend them. Take the stems, add some vegetable stock, some oregano, maybe a little garlic, and you've got yourself a soup or a blended sauce. The bioavailability of the sulforaphane doesn't drop. You're still getting the full benefit. You're just changing the texture. The second thing I want to highlight is broccoli sprouts. And this is where it gets almost unbelievable, to be honest. 3 to 4 day old broccoli sprouts, the tiny ones you can find in health food stores or grow yourself very easily at home, contain roughly 100 times more sulforaphane than mature broccoli. Per gram, 100 times. That's not a rounding error. That's a completely different ballgame. And I'll tell you about a study that really stuck with me. Researchers took a group of healthy 20-year-olds and gave half of them a broccoli sprout shake alongside a flu vaccine. The other half just got the vaccine. When they measured the immune response, specifically how well the immune system mounted a defense against the flu, the broccoli sprout group showed an immune response that was 22 times stronger than the control group. 22 times, with a shake made of sprouts. Now, I want to be careful here. This doesn't mean you should replace your flu shot with broccoli. The vaccine is doing the priming. It's giving your immune system the blueprint of what to fight. But the sulforaphane in the sprouts essentially hands your immune army better weapons, better training, better equipment to execute the fight. The combination is what's remarkable. And the practical takeaway is almost too simple. Broccoli sprouts are cheap, they're easy to grow at home with a mason jar and a mesh lid. And a small handful in a morning smoothie is genuinely one of the most potent immune-boosting things you can do. Now, let's shift to blueberries. And I want to approach this one a little differently. because I think blueberries present us with a really elegant solution to a problem that comes up a lot in conversations about immunity. The problem is this: when people hear boost your immune system, they often conceptualize it as a dial that goes from 0 to 100, and the goal is to crank it up to 100, as high as possible. But that framing is actually a bit dangerous, because an overactive immune system isn't healthy. It's what we see in autoimmune conditions. It's the body attacking itself. The goal isn't maximum immune activity. The goal is optimally calibrated immune activity. High performance without runaway inflammation. And this is where blueberries become interesting. The deep blue-purple color of blueberries comes from a class of pigments called anthocyanins. These aren't just pretty colors. They are biologically active compounds that interact with your immune system in a very specific way. Research has shown that consuming around 1.5 cups of blueberries per day can elevate your T-cell count by approximately 88%. That's a very significant increase in one of your primary immune defense populations. But here's the elegant part. Simultaneously, anthocyanins also act as anti-inflammatory agents, meaning they help bring down systemic inflammation. So you're getting an upregulation of your immune surveillance cells, more T cells, more natural killer cells on patrol, while at the same time getting a downregulation of the background inflammatory activity that contributes to everything from cardiovascular disease to cognitive decline. It's a 2-for-1 that's genuinely hard to replicate pharmacologically without side effects, because most things that ramp up immune activity also ramp up inflammation. They're closely linked pathways. The fact that anthocyanins can decouple those two responses is, from a biochemistry standpoint, quite remarkable. And I think the broader lesson here is one worth internalizing. The goal of a healthy diet isn't to push any one biological parameter as high as it can go. It's about calibration. It's about giving your body the tools it needs to maintain balance. Blueberries are a beautiful example of a food that doesn't just push one lever. It helps your system find its optimal setting. Practically speaking, 1.5 cups a day. That's it. Toss them in oatmeal in the morning, blend them into a smoothie, eat them straight from the container. I do this constantly. Fresh or frozen, the anthocyanin content is largely preserved either way. All right, I've saved what I think is one of the most mind-bending pieces of research for last, and it involves one of the most underrated fruits in existence, the kiwi. I'll be honest, kiwi doesn't get a lot of headlines. It doesn't have the cultural cachet of blueberries or the centuries of medicinal lore that surround green tea. But when you look at the data on what this little fuzzy fruit is doing at the cellular level, it's frankly extraordinary. Let's start with DNA. Your DNA is under constant assault. Every single day, the normal metabolic processes of your body, breathing, converting food to energy, everything, generate what we call reactive oxygen species, or free radicals. These molecules attack your DNA, causing oxidative damage. On top of that, you've got environmental exposures, UV radiation, pollution, certain compounds in processed foods. This damage is happening right now in every cell in your body. The question isn't whether DNA damage occurs. It always does. The question is whether your body's repair mechanisms can keep up. And here's the remarkable finding. Consuming just 1 kiwi per day has been shown to protect DNA from oxidative damage by approximately 60%. 1 kiwi, 60% reduction in oxidative DNA damage. The mechanism is largely attributed to the very high vitamin C content in kiwi. Gram for gram, kiwi actually contains more vitamin C than most oranges, along with other antioxidant compounds that work synergistically to neutralize those free radicals before they can do damage. But it gets better. When you increase your kiwi consumption to 3 per day, the research shows not just protection from new damage, but active repair of existing damage. The body's DNA repair enzymes appear to be significantly upregulated, and the observed effect is approximately a 60% improvement in DNA repair rates. Let me just pause on that for a second. Your DNA, the blueprint of everything you are, every protein your body makes, every cellular function you have, can be actively repaired. And eating 3 kiwis a day may meaningfully accelerate that repair process. Now, the second superpower of kiwi is one that has become increasingly interesting to me as the gut microbiome research has exploded over the last decade. Kiwi is an exceptionally good source of prebiotic fiber, specifically a type of fiber that selectively feeds beneficial bacterial species in your gut. There was a study out of Singapore that I found particularly striking. Participants consumed kiwi regularly, and the researchers tracked changes in their gut microbiome. What they found was that the fiber in kiwi produced a measurable, significant shift toward healthier bacterial populations, and this shift occurred overnight. Not over weeks, overnight. Your gut microbiome, which we now understand influences everything from immune function to mood to metabolic health, is extraordinarily responsive to what you eat. More responsive and more quickly than most people appreciate. And the kiwi data illustrates that beautifully. One day of making a different choice, and you have a meaningfully different microbial community working for you inside your intestinal tract. That, to me, is one of the most empowering pieces of nutritional science I've ever come across. It means it's never too late, and it never takes as long as you think to start making a difference. So let me bring this all together with what I think is the most important idea of everything we've discussed today. When I went through medical training, and when I think about the way most nutritional advice gets delivered, by doctors, by dietitians, by public health messaging, it's almost always framed around subtraction. Cut the sugar, eliminate processed food, avoid red meat, stop drinking, stop eating late. And look, some of that guidance has merit. I'm not here to tell you that a diet of fried chicken and soda is fine. It's not. But here's what I've observed in clinical practice. Telling people what to take away doesn't work. Not because people are lazy or undisciplined, but because human psychology is fundamentally wired toward abundance, not deprivation. When you tell someone they can't have something, the entire relationship with that food changes. It becomes forbidden, desirable, and the mental energy of white-knuckling through restriction is exhausting and ultimately unsustainable. What does work, and this is what the research supports and what I now actively counsel my own patients toward, is focusing on addition. Instead of thinking about what you can't have, think about what you can add. Add a cup of blueberries. Add broccoli sprouts to your smoothie. Swap your afternoon coffee for a green tea 2 or 3 times a week. Add a kiwi to breakfast. Cook your tomatoes with a little olive oil. By the way, that's the nuance about tomatoes I mentioned earlier. The bioavailability of lycopene, the anti-angiogenic compound in tomatoes, actually goes up significantly when the tomatoes are heated and consumed with a fat. So tomato sauce with olive oil is not just delicious, it's biologically superior to raw tomatoes in this specific context. When you focus on adding these foods, something interesting happens. Your plate naturally starts to get more crowded with the good stuff, and the less useful stuff just starts to take up less real estate. Not because you're denying yourself, but because you're genuinely choosing something better. Your body is doing extraordinary things on your behalf, right now, without you having to think about it. It's patrolling for aberrant cells. It's repairing DNA damage. It's calibrating immune responses. It's managing blood vessel growth. All you have to do is give it the raw materials it needs to do those jobs well. And the beautiful thing, the thing that keeps me genuinely excited about this intersection of nutrition and medicine, is that your body responds fast. Faster than most people expect. The microbiome can shift overnight. Immune populations change within days of dietary shifts. The systems are responsive and resilient. So here's the only question I want to leave you with. If your body has the inherent power to repair its own DNA, to starve microscopic threats, to keep you protected, and if that process starts almost immediately when you give it the right tools, what is one food you're going to add to your plate today to help it do its job? Start there, just one food, and see what happens next. I'll see you in the next episode. Take care of yourselves.